Hello, everyone. A few days ago, I saw a newspaper article about how Keytruda is the dominant drug product of Merck. And they said that in 2021, they're on track to make about $18 billion in sales of Keytruda. So then I was just curious what the number one drug in the world was. And it is actually Humira, which is by AbbVie. And last year they made $20 billion in revenue. And what's interesting is both Humira and Keytruda are monoclonal antibodies. So Humira is actually called adalimumab, and that's a monoclonal antibody. And Keytruda is pembrolizumab, and that's also a monoclonal antibody. And then I realized that this may signal kind of the end of generic drugs because most drugs previously are very simple molecules. So, as an example, this is molnupiravir. It's a very simple molecule. It looks like this, has a molecular weight of like 320. And then the number four drug on this list is Eliquis, which is a blood thinner, also called apixaban. And it's this. It's a very simple molecule. So these simple molecules like this and like this can be synthesized by organic chemistry methods. So a generic drug maker, once these go off patent, an organic chemist can look at the structure and say, we can synthesize this in the lab. And this is you can replicate this drug. It's not extremely difficult. And so then once it gets off patent, generic drug makers can make it, and then the price of the drug goes down. In contrast, the structure of a monoclonal antibody is 150 kilodaltons. So this is 300 daltons. So a monoclonal antibody is about 500 times larger than this. And so, like on this, molnupiravir would be just like one little dot here in this giant thing. And you cannot make this through any kind of synthetic chemistry method. These things can only be produced within a biological system. Like only the machinery, the complex machinery of a cell, of a living cell, can construct this thing. And so the way that monoclonal antibodies are made, I made a whole video talking about the history and how monoclonal antibodies are made. But basically, there's several ways to make them, but they all use cells, and you either clone the DNA sequence of the antibody into a cell, or you find the cell and then you make a hybridoma. And it makes a very unique molecule that cannot be replicated without having the exact genomic sequence or the actual cell line that it's cloned into. And of course, these companies are not obliged to provide the DNA sequence. And even if you had the DNA sequence, I'm not too sure that we have the technology currently to replicate the entire DNA sequence of an immunoglobulin. That's an extremely large molecule. Oh, and they're not going to give their cell lines to a generic drug maker. A generic drug maker usually looks at these structures and they will reverse engineer and figure out their own way to synthesize it. But without having to do like some kind of corporate espionage and steal these things, a generic drug maker cannot get the sequence and cannot get the cell lines to replicate these monoclonal antibody drugs. So essentially, the most popular drugs are now monoclonal antibodies, and they're bringing in billions of revenue for these pharmaceutical companies. And essentially, a generic can never be made of these things. So even if they go off patent, there will not be a generic variant of pembrolizumab or adalimumab, which is kind of an interesting turn of events that medicine has gone to, that we now have drugs that are so unique and difficult to make that a generic drug for these things cannot happen, which I'm sure the pharmaceutical companies love. But yeah, it was just an interesting thing that became obvious after looking at these things. Anyway, I hope that this was interesting to someone else other than me. I just thought it was interesting when I found out about it and thought we'd make a video about it. Thanks for watching.